Hello dear students, today we are going to derive the trigonometric identities and we will solve some of the questions based on that identities. See, the first trigonometric identity is sine square a plus cos square a is equal to 1. So first of all, let's prove this identity. So to derive this, let's take the triangle ABC, which is right angle at B. So here for this right angle triangle, if you use the Pythagoras theorem, then we can write this AB square plus BC square will be equal to hypotenuse square, that is AC square. Now here, if you divide both sides by AC, so divide both sides by AC square. So if you divide here this AB square divided by AC square plus this BC square divided by AC square is equal to this side, this AC square divided by AC square. So if you divide by AC, so here this AC square will be cancelled out right hand side. Here AB square divided by AC square. So we can write this as AB divided by AC whole square plus this is BC divided by AC whole square is equal to your AC square cancel out, so we get 1. Now this AB divided by AC. So if you consider this angle A here, then this AB is the adjacent side and AC is the hypotenuse. So AB divided by AC, that can be written as adjacent side divided by hypotenuse, that is equal to cos A, or you can write this is cos square A. Same way here, BC divided by AC. So BC is the opposite side and AC is the hypotenuse. So opposite side divided by hypotenuse, that is known as sine square A. So this is how we can derive the first identity. This is sine square A plus cos square A equal to 1. Now let's move to the next identity. The second identity is a sec square A minus tan square A equal to 1. And to derive this identity, we will use the first identity. We have already derived that sine square A plus cos square A equal to 1. Now here if you want to prove that sec square A minus tan square A equal to 1, so divide this identity by cos square A. So let's divide sine square A plus cos square A equal to 1 by cos square A on both sides. So here if you divide the sine square A divided by cos square A plus here this cos square A divided with cos square A. Here 1 is divided by cos square A. So here we can see sine square A divided by cos square A. So ratio of sine and cos is nothing but the tan A. So sine square A divided by cos square A is equal to tan square A. Plus here this cos square A will be cancelled out, so we will get 1 and 1 divided by cos square A. So reciprocal of cos A is equal to sec A. So 1 upon cos square A, that become sec square A. Now if you take this tan square A to the right hand side, then we will get this required equation, sec square A minus tan square A will be equal to 1. So this is how we can derive the second identity. Second identity is sec square A minus tan square A equal to 1. And now let's see the third identity. The third identity is cosec square A minus cot square A equal to 1. So this is also derived from the first identity, that is sine square A plus cos square A equal to 1. In the previous identity, we have divided this identity with cos square A. Now here we will divide this identity with sin square A. So divide by sine square A on both sides. So here we got the sine square A divide with sine square A plus this cos square A divide with sine square A. Here this 1 divided by sine square A. So here this sine square will be cancelled out, so we will get 1. Here this cos square A divided by sine square A. So ratio of cos and sine is nothing but the cot A. So this cos square A divided by sine square A, that become cot square A is equal to, here 1 upon sine square A, that become cosec square A. And if you take this cot square A to this side, so this plus cot square A become minus cot square A. So we can write this is cosec square A minus cot square A is equal to 1. So this is the third identity. So this is how we can derive all three identities. And based on this three identity, first identity sine square plus cos square equal to 1, second sec square minus tan square equal to 1, and third cosec square minus cot square equal to 1. Let's solve some of the questions. See the first question. Prove that sec A multiplied 1 minus sine A multiplies sec A plus tan A is equal to 1. So here let's start with the left hand side. Left hand side is given sec A multiplied 1 minus sine A multiplied sec A plus tan A. And we have to prove that this equation is equal to 1. So to simplify this, let's convert this all the trigonometric ratio in the form of sine and cos. So we can write this sec A as 1 upon cos A. Here this 1 minus sine A, that is as it is. Here sec A, that can be written as 1 upon cos A plus this tan A. So tan A is the ratio of sine A and cos A. Now here this will be as it is, this 1 minus sine A divided by cos A. This is 1 minus sine A. In denominator we have cos A. Here if you take the LCM, so LCM is cos A, and on the numerator we will get 1 plus sine A. Now here those two brackets are in the multiplication. So this 1 minus sine A multiplies 1 plus sine A, so it becomes 1 minus sine square A. You can use the identity A minus B A plus B, that is A square minus B square, that is 1 minus sine square A. And here in the denominator, this cos A multiplies cos A, that becomes cos square A. And here we know the identity, that is sine square A plus cos square A is equal to 1. But if you take this sine square A to this side, so we can write cos square A is equal to 1 minus sine square A. So here in place of 1 minus sine square A, we can write cos square A. So this becomes cos square A divided by cos square A, that is equal to 1. This is what we need to prove. Here this left hand side is equal to right hand side. Hence this question is proved. Let's see the next question. Here we have to prove cot A minus cos A divided by cot A plus cos A is equal to cosec A minus 1 divided by cosec A plus 1. So let's start with left hand side. On the left hand side we have cot A minus cos A divided by cot A plus cos A. So if you convert this cot in the form of sine and cos, so we can write cot A is the ratio of cos A and sine A minus cos A, take it as it is. Here in the denominator also we can write this cot A as cos A divided by sine A plus this cos A as it is. Now here from the numerator, if you take those two terms. So from those two terms we can take cos A common. So if you take cos A common from the numerator, so here we will get 1 upon sine A minus 1, and same thing in the denominator. If you take cos A common from the denominator, so we'll get 1 upon sine A plus 1. So here this cos A will be cancelled out. 1 upon sine A, that is reciprocal of sine A, is cosec A. So we can write in the numerator, that is cosec A minus 1, and denominator is equal to cosec A plus 1. So that is what we have on the right hand side. So here we get left hand side is equal to right hand side. Hence, see, the next question is, prove that cosec theta minus cot theta whole square is equal to 1 minus cos theta divided by 1 plus cos theta. So here if you see, if you start from the left hand side, on the left hand side we have cosec and cot, and on the right hand side we have 1 minus cos upon 1 plus cos. So we have to convert this cosec into the form of sine and cos. So let's take this left hand side, cosec theta minus cot theta whole square. So you can write this cosec theta is written as 1 upon sine theta, and cot theta can be written as cos theta upon sine theta whole square. So here if you take the LCM, in the denominator we have sine theta, and on the numerator we have 1 minus cos theta whole square. So if you take this square into the bracket, so it will become 1 minus cos theta whole square divided by sine square theta. Now on further simplification, this 1 minus cos theta whole square, that can be written as 1 minus cos theta multiplied with 1 minus cos theta, and here in the denominator sine square theta, that can be written as 1 minus cos square theta, because we know the identity sine square theta plus cos square theta equal to 1. So sine square theta will be equal to 1 minus cos square theta. And now here this 1 minus cos square theta, so here you can use the formula a square minus b square, that will be equal to a plus b, a minus b. So this 1 minus cos theta become 1 plus cos theta into 1 minus cos theta, right? So a square minus b square become a plus b, a minus b. So here 1 minus cos theta, 1 minus cos theta cancel out. So here we get 1 minus cos theta divided by 1 plus cos theta. This is what we have on the right hand side. So here we have proved left hand side is equal to right hand side. See the next question. We have to prove cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 sec A. So let's start with the left hand side. We have cos A upon 1 plus sin A plus 1 plus sin A divided by cos A. Now here if you take the LCM, this will cos A multiplied cos A, will do the cross multiplication, this becomes cos square A plus this 1 plus sin A multiplied 1 plus sin A, that becomes 1 plus sin A whole square divided by the denominator we have cos A plus multiply with 1 plus sin A. Now here if you simplify the numerator, if you expand this bracket 1 plus sin A, so this become this is cos square A plus this A plus B whole square, that become A square plus B square plus 2AB and the denominator, that is, as it is cos A multiplied 1 plus sin A. Now here in the numerator, this is cos square A plus sin square A. So this will be 1, cos square plus sin square equal to 1, and 1 plus this 1, that become 2. So here we get 2 plus 2 sin A, and in the denominator we have cos A to 1 plus sin A. Now if you take 2 common from the numerator, so in the numerator we get 2 multiplied 1 plus sin A, and in the denominator we have cos A into 1 plus sin A. So this 1 plus sin A, 1 plus sin A will be cancelled out, so we get here 2 upon cos A, and this cos A, the reciprocal of cos A, that will be sec A. So we get 2 multiplied sec A, that is what we have in the left hand side. So this is how we can prove the different question using the identities. In the next lecture we will see more questions like this.